So today academic all right, so today academic daddy will be teaching you everything you need to know with regards to the Lewis structure of ionic compounds. So there you have it. The first one said write plausible Lewis structure for NO plus. So when I have that is A, so I have NO plus. So first of all, using our rule, the first principle is to find the number of electrons in this. So nitrogen has valence electron, number of electrons in that atomic shell to be 5. Oxygen has 6. So 5 plus 6 is 11. 11. Now plus, when you see plus ion, it means that it lost an electron. It lost an electron to have more positive. So that means to represent that we do minus 1. Assuming it's minus here, it will be plus 1. So since it's plus, it means it lost an electron. So 11 minus 1 is equals to 10. So once we are through with that, once we are through with this, let's now go to the second step, which is to draw the skeletal structure. I'll just do N and O. Now we have 10 electrons remaining to share. Now before we share, we ask ourselves how many bond is this? Just one bond. On every bond there is 2 electrons. So we do 10, we do at this point 10 minus 2, which is equals to 8. So the total number of electrons to share is 8. So start from the right. I have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So these are the 8 electrons. So this is the 8 electrons. Now that I have the 8 electrons, oxygen is balanced. Nitrogen is 1, 2, 3, 4. It's not balanced. So let's try to carry a lone pair here. So if I carry down lone pair, I will now have that this is now NO. Then when it comes down, when the lone pair comes down, this becomes this way. Then I have O. So this is 1, 2, 3, 4, 5, 6, 7, 8. Oxygen is still balanced. Then nitrogen 1, 2, 3, 4, 5, 6 is not balanced. Let's carry this lone pair. So if we carry the lone pair, if we carry it, we are carrying it. Let's carry it and now redraw this to see if it will work. Already we have this way, then we have this one, we have this one. So if we are carrying the lone pair down, it means that this will become 3 bonds, and we are left with just this one. So let's check if it's balanced now. We have 1, 2, 3, 4, 5, 6, 7, 8 for oxygen. Nitrogen 1, 2, 3, 4, 5, 6, 7, 8. So it's balanced. So this is the Lewis structure. This is the Lewis structure. This is the Lewis structure. So let's move to second question. N2H5 plus. So the B part is N2H5 plus. That is 2 nitrogen. That is, first of all, let's check how many electrons are in this compound. We have nitrogen, the valence electron is 5. Then it has 2 plus. Hydrogen is 1. Then it's having 5 here. Now, this is the sentence saying equals to. Plus means 1. Just 1 plus. So that by the time I do this very well, I'll now have this to be 10 plus 5 equals to 1, which is 15 equals to 1. This is the sentence as 15 minus 1 equals to 0. So we have 14 electrons. So if you don't understand it this way, you can as well do it that once you finish, you remember that you ought to, since this is plus means that it lost an electron, so you must minus 1. When it's negative, you know that it's added. So since we've gotten the number of electrons in this compound, the next is to present the skeletal structure. So the skeletal structure will now have that I have 2 Na, that is nitrogen. Once you see this, we have 5 hydrogens there. Rush and find a way to attach those hydrogens, so that each one, hydrogen is always looking for a way to attach itself so that it will have just one bond. Don't come and be doing 5 hydrogen, H, H. Say for example you start doing things like this, you will be very mad, because first of all this is now 1 2 4 electrons for this hydrogen. The same thing here, so this is wrong, this is wrong, this is wrong. So once you are doing empty hydrogen, find a way to attach it in such a way that it gets out of the way. So I now attach the remaining hydrogen here, and let's say I attach the remaining hydrogen here. So I've exhausted the 5 hydrogens. Now remember that the number of electrons in this compound is 14. Now let's ask ourselves, how many bonds do we have here? We have 1, 2, 3, 4, 5, 6. We have 6 bonds. 6 bonds. So that's 6 bonds. On each bond there is 2 electrons. So that is the same thing as 6 times 2, 12. So that is the same thing as 14 minus 12 is equals to 2 electrons. So this is remaining just 2 electrons to share. Just 2. So hydrogen. Remember I said the third step is to always start from the terminal to add electrons. But once you see hydrogen, you cannot start from hydrogen to add any electron because it's already complete. 1 2 for hydrogen. You don't add to hydrogen. When you see hydrogen at the end, any other compound before it, that's where you call your terminal. So that 2 electrons, I add it here. 1 2. So when you check this now, this nitrogen is 1 2 3 4 5 6 7 8. This nitrogen is 1 2 3 4 5 6 7 8. So this is the lowest structure. This is the lowest structure. So let's move to number C. Let's move to C. C is giving us O2 minus. C is giving us O2 minus. Now I tell you, there's nothing like O2 minus. What we have is O raised to power 2 minus. And this is an ion that you find in most metallic oxides, or you say in most alkaline and alkaline earth metals such as sodium, magnesium and the rest. So even in some cases you have it in lithium. So you just need to know that this is what you have. And if you have this kind of thing, to draw the lowest structure is simply you trying to present it. You know that since it's having 2 minus this way, it means it's added 2 electrons. So if you know this, when you find this kind of element in this kind of ion in water, it hardly happens. But in a case where you have it in OH minus, you see that if you have it this exactly like this in the water molecule, it will make it to should I say lose much proton. So it's not found in water. So this question is wrong. So assuming the question asks you to find O2, that's where you have issues. So because to find O2 is simply saying oxygen is 6. This is the same as O and O and O, and oxygen is 6 and 6. So this is the same thing as 12. 12. If I have 12 and I know that since it's 12 now for oxygen, and I have a bond between them, so I'll do 1 times 2, which is 2. So on every bond there is 2 electrons, 1 2, so equals to 10. So I have 10 electrons to share amongst this, so that I have that 10 electrons. I will now say 1 2 on the right terminal, 3 4 5 6 7 8 9 10. So notice this, I've exhausted the electron. So since I've exhausted the electron, I see this, I carry this lone pair, I carry that lone pair. Once you've exhausted the electron, the next thing is to carry the lone pair, so that I redraw this now. If I carry that lone pair, I will have that this is this one. That lone pair that you carried, put it here, so that this becomes 1 2 3 4 5 6 7 8 for this oxygen. 1 2 3 4 5 6 7 8 for this oxygen is balanced. So it's oxygen that you're supposed to have there, not O2 minus. So it's not correct. So let's move to the fourth one. Boron fluoride Bf4 minus. That's the fourth one. Boron is number 5 in the periodic table. Hydrogen, helium, lithium, beryllium, boron. So that means 2 in the inner shell, K shell, then 3 in the outer shell. 3 plus fluorine is in group 7. It has 7 electrons in the outermost shell. 7 all into 4 equals to minus 1. So this is the sentence as 28 plus 3, which will give you 2 here, 30 plus 31. So this is 29, 30, 31. This is 31 equals to minus 1 equals to minus 1. This is something as 31 crossing over becomes plus 1 equals to 0. Equals to 0. So this is 32. So if you know this to be 32, the second step is that which one is more electronegative? Fluorine is more electronegative, is higher in the atomic table on the periodic table. So boron will become the central carbon because it's less electronegative. So let's put fluorine here. Let's put fluorine here. Let's put fluorine here. And let's put fluorine here. So the minute I put this fluorine, I count the bonds. I have 1, 2, 3, 4. 4 bonds means 4 times 2, which is the sentence as 8. So 32 minus 8. 32 minus 8. So 32 minus 8, that is 4 times 2 equals to 8. So if I remove 8 from 30, I have 22. Then if I put the 2 there, is 24. So this is the sentence 24. So if I have 24 electrons remaining, let's share it. So that this now becomes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there you have it for boron fluoride. This is how the ion, the boron ion, this is how you have it. So let's move to the next question. So over here we have nitrogen, which is having 5 electrons in the atomic shell. We have hydrogen, which is having 1 and it's by 3 here. It's in 3. It's triatomic. Plus oxygen, it has 6 in the atomic shell. Plus all equals to plus 1. All equals to plus 1. So this is the sentence saying 5 plus 3 is 8. 8 plus 6 is 14. 14 plus 1 is 15. So 15. See it. 7. 7 plus 3 is 10 and 15 equals to plus 1. So this is something as 15 minus 1 equals to 0. Always know that when the ion is plus, you must subtract that ion from the electron. But when it's negative, you must add it. Because if it's showing you plus, it means that it lost an electron to become more, to have more of protons, which is indicating this positivity. So this is now 14 electrons. So let's now analyze this. Let's move to the second step where we draw the skeletal structure. So drawing the skeletal structure, I have that this is N. Once you have this N, make sure or try to see that it gets surrounded by the hydrogen, so you don't make space for hydrogen to be alone and then start attaching and then move to have more than 2 electrons. So once I have this, now I've succeeded in putting this to its place. Now the next part is the O. So I draw a bond, put for O, then a bond, put this H. Now once I'm through with this, you can see automatically that this is not complete. For this, but that's not our goal. Once we are through with the skeletal structure, let's count the bond electrons. 1, 2, 3, 4, 5. We have five bonds, which means 5 times 2. On each bond there is 2 electrons, so 5 times 2 is 10. So this is something as minus 10 electrons, which is equals to 4 remaining. We have 4 to share here. So this right terminal, I told you always start from the right terminal. Always start from the right terminal. When you see hydrogen there, don't put anything on it. So 4, just 1, 2, 3, 4. So that is it is balanced. 1, 2, 3, 4, 5, 6, 7, 8 for oxygen. Then this is 1, 2, 3, 4, 5, 6, 7, 8 for nitrogen. So it's balanced. Let's go to the last question. The last question under your textbook. I will impregnate you academically. So please remember to subscribe, share, like. I love you. Now NCO minus, the valency of nitrogen is 5, carbon is 4, oxygen is 6, all equals to minus 1. So when you plus it, this is 4 plus 6 is 10. 4 plus 6 is 10. 10 plus 5 is 15, equals to minus 1. Whenever you see minus, it will definitely add up. This is 15 plus 1 equals to 0. So 16 electrons. So 16 electrons. Now let's move to the skeletal structure. Skeletal, we will now do to the skeletal structure. All we have to do is to singly put this so that I have NC. Notice that nitrogen and oxygen are higher in the periodic table than carbon. So carbon is the least, so it has less electronegativity. When it comes, it will bring lesser electron. So I now put O here. So the minute I put O, let's count the bond electrons. I have 1, 2. So 2 means that it has 4 electrons. 1, 2, 1, 2. So 4 electrons. So I'll do 16 minus 4 is equals to 12 electrons remaining. So if I get that, I will come the 12 electrons that are remaining. I'll start by the right hand. With the right hand side, I'll do 1, 2, 3, 4, 5, 6. Don't come and do, let me share it equal. Complete the right before moving to the left. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these are the 12 electrons. See how I've shared it. But notice that after sharing it, carbon does not have a complete electron. Does not have complete electron. This is all 1, 2, 3, 4. So to make it complete, now once you are through with it, or once you've exhausted all electrons, start by carrying the bond. So the lone pair, sorry, carrying the lone pair. So if I carry this lone pair now and put here, I will have any. Let me draw everything I have. Now since I'm carrying this lone pair and carrying this lone pair, so let's check. Is carbon balanced? I have 1, 2, 3, 4, 5, 6, 7, 8 for carbon. Assuming it did not balance, I'll still come and carry this. Once you carry this, I'll carry for this side. So oxygen, this is now 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's balanced. It's balanced. So please remember to like, share, subscribe. It's academic daddy. Your academic daddy. So any question you have, you put it in the comment section. So this is it, balanced. This is it, balanced. So when you check it, you know.